If you look at your hands, you are holding the secret to the easiest math in the world. Humans naturally count on 10 fingers, which means our brains are heavily wired to work in groups of 10. The metric system leans right into this natural habit. It functions much like a high-end camera's zoom lens. To measure things that are bigger or smaller, you don't need to invent entirely new words or memorize complicated fractions. You zoom in or out by adding or moving zeros. To make this system work, we first need a baseline to zoom from. For measuring length, that baseline unit is the meter. You can picture a single meter as the length of an acoustic guitar, or the distance you cover in one large step. Every distance measurement in the metric system, from the gap between galaxies to the width of a human hair, is just this single meter, zoomed in or out. To measure the distance to the next town over, placing standard meters one by one isn't practical. We need to zoom way out. We do this by taking our baseline meter and multiplying it by 1,000. This scales the unit up to create the kilometer. If we want to measure a tiny detail, like an insect resting on a leaf, the meter is too big. We must zoom in tight. To get there, we divide our baseline meter into 100 equal pieces. Each of those tiny slices is called a centimeter. This diagram shows how prefixes connect measurements. Following the top arrows reveals multiplication rules for breaking larger units down. Kilometers multiply by 1,000 to become meters, which multiply by 100 to become centimeters. Going the reverse way means dividing by multiples of 10. Measuring straight lines in the metric system is predictable. Because you are only ever multiplying or dividing by tens, you avoid the headache of memorizing unrelated units, like 12 inches in a foot or 3 feet in a yard. Straight lines are perfect for distances, but we need a different approach to measure flat space inside a room, like an empty hardwood floor. A single line doesn't account for depth. Physical space requires 2 dimensions, length and width. To calculate that space, we find the area. You measure the length in meters, measure the width in meters, and multiply them together. This gives us a new way to describe space, the square meter. This unit is built by combining our 2 measurements together. Area measurements account for every point on a flat surface, moving beyond the single line of a distance measurement. When we need to measure a tiny surface, we zoom in again and use the square centimeter. If you drop a massive 1 meter square next to a tiny 1 centimeter square, the difference in scale is obvious. Here is where beginners usually make a mistake. Because there are 100 centimeters in a standard meter line, it's easy to assume there are only 100 square centimeters inside a square meter. Since area has 2 dimensions, we apply our scale twice, once for length, once for width. A square meter measures 100 centimeters across and down. When you multiply 100 by 100, you find the real rule. Exactly 10,000 square centimeters fit inside a single square meter. Whether you are tracking the distance of a long drive or mapping the floor space for a new rug, the math relies on the same base 10 logic. By just shifting zeros, you can measure anything in the universe.